firing. And so they're going to fire off and become depolarized. And when I say fire, I basically mean become depolarized. So they're going to become depolarized themselves because they hit their threshold for doing so. And so they become depolarized. And then they have some positive ions. Again, depolarization means you have lots of positive ions floating around inside of you. They're going to have some positive ions that kind of float into their neighboring cells. And so now more cells are going to kind of. So we've talked about pacemaker cells, and I thought it'd be kind of neat to draw out again exactly what these pacemaker cells do and compare them to one another. So we know we have different types of pacemaker cells, and I'm going to use our millivolt scale just as we usually do to kind of compare them. So the first type is our S, okay? It's 0.66, something like that. So that's how long it takes for the SA node to fire off one beat. And in fact, just to really hammer home the point, that's this distance right here, right? That's 0.66 seconds. So now for the AV node, we can do the exact same thing. We can say, well, the AV node we know usually is somewhere between 40 to 60 beats to the left atrium through what we call Bachmann's bundle. That's just a name for that little band of tissue. So Bachmann's bundle is that little band of tissue that heads over the left atrium. And then there are a few other bands that actually head down this way to this node of tissue, so the second node of cells, and these paths are called the meaning between, intranodal tracts. So you have these three intranodal tracts taking the ions that are in one cell will actually start leaking into the next cell. So if you've got a few positive ions in one cell, they'll leak into the next cell and make it slightly less negative. And that's actually really important for depolarization. Now, the way I'm going to show depolarization is that all these cells, they have a little negative sign in them, right? So these negative signs represent the membrane potential. So, for example, we know that the negative sign in this muscle cell probably represents somewhere around negative 90 millivolts, because that's usually where these cells like to. This is the race, right? The SA node is basically trying to get a signal over there quickly. And these distances that it has to cover, we said about 2 centimeters and about 1 centimeter. So what is the math? How does that work out? So you can actually look up these numbers, and it turns out that if you check it out, these conduction velocities are really, really fast, right? So it's about 0.5 meters per second up here, and it gets even faster as you get along further, so it's about 2 meters per second. So these are the velocities of the signal, how fast the